In this video, we're going to prove that the sum of the squares of the first n positive integers equals 1/6n times n plus 1 times 2n plus 1. We're going to be using proof by induction, so we need to show that the first case is true, and then that each case implies the next, so that all cases must be true. So we'll start with our first case. If we plug in n equals 1, we'll get 1 squared equals 1/6 times 1 times 2 times 3, which indeed equals 1. So our first case is true. Now for our proof, we'll assume that the statement holds for n. So we'll assume that 1 squared plus 2 squared plus n squared equals 1/6n times n plus 1 times 2n plus 1. What we want to show is that 1 squared plus 2 squared plus n squared plus n plus 1 squared equals 1/6 times n plus 1 times n plus 2 times 2n plus 3. And this comes from plugging in n plus 1 into our original statement. So our goal is to get to this. So what we start with is what is on the left side. So you would let n be any positive integer and assume that the statement holds for the nth case. Now, since we want to prove this, we'll start with that on the left side. So 1 squared plus 2 squared plus n squared plus n plus 1 squared. Well, we know that the first half, or the first part of this, equals 1/6n times n plus 1 times 2n plus 1 by assumption, so that this statement equals. Now we can notice here that we have an n plus 1 in both terms, so we can factor that out. And since our goal is to get to this, I'm going to go ahead and factor out the 1/6 as well. So we can set this equal to 1/6 n plus 1. Factoring that out, we're left with an n, a 2n plus 1, and then since we factor out a 1/6, we'll have plus a 6 times n plus 1. Now we just simplify this inside part. So on the outside, we still have 1/6 n plus 1. Here, if we multiply this out, we'll get 2n squared plus n plus 6n plus 6. And we can combine like terms and factor this. So we'll have 2n squared plus 7n plus 6, which factors into 2n plus 3 times n plus 2. And then we still have 1/6 times n plus 1. But this is exactly what we were trying to prove, which is a given statement with n plus 1. So we can say that the statement is true for all positive integers. Just to recap, we start with our base case. We plug in 1 on both sides. The statement is indeed true. Then we assume that the statement holds for some arbitrary n and show that it is true, must be true for n plus 1. And then by induction, we can say that the statement is true for all n.